Hello class, this is your instructor, Ms. Birchfield. In this mini lesson, we're going to solve quadratic equations using the quadratic formula. So going back, what is a quadratic? Well, a quadratic is an equation that is a second degree equation, meaning the highest exponent is a 2. And it has to be in this form called standard form, where we have a trinomial that has the x squared term, the x term, and a constant. And the square term, we want it in descending order. And the coefficients in front of the terms, the square term is your a, your x term is the b coefficient, and then your c is your constant. Remember, constant is just a number. So how do we solve a quadratic equation that would not factor? So in a previous lesson, we solved equations by factoring and quadratic equations using the slip and slide and diamond method. Well, what if you had a quadratic equation that would not factor or break down using the slip and slide? Well, we can solve that quadratic using the quadratic formula, which is this formula right here. So to solve a quadratic with this formula, what we need to do is we need to have the equation in standard form. Remember, standard form is this form here, and we want to make sure it's in descending order. Then we will identify the coefficients for A, B, and C. We will substitute those numbers into the formula. And then we will simplify the discriminant. The discriminant is what's underneath this radical, what's under your square root. We're going to simplify that. And then we will simplify the fraction where possible. So this first example, I could see if it would factor. In fact, I think this one will, but I'm going to actually I'm going to use the quadratic formula to show you how you can solve a quadratic equation using this formula. I need to make sure it's equal to 0. And then once I do that, then what I'm going to do is I'm going to identify the A, B, and C. So the coefficients of the terms are your numbers you're going to use to substitute into the equation. So the quadratic formula, I will write it out, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that means everything in the numerator, you need a line under it with the 2a on the bottom. So we will substitute in. All right, in place of our variables, what I'm going to do here is I'm going to substitute. So for b, b is a positive 16, so it's the opposite of 16 plus or minus the square root of, instead of b, I'm going to put in my 16 again. So I'm going to have 16 squared. And then I'm going to bring my minus down, and I'll bring my 4 down, and then I'm going to replace the a with the 3. So I'm going to say 4 times 3. Just trying to use different colors here. And then times 5 for c. And then that's going to be all over 2 times our a, which is 3. So what we're going to do now is we're going to simplify under the discriminant. So I'm just going to kind of bring down the negative 16. Calculator comes in handy if you're not sure, of squaring something, but 16 squared is 256. And then I'm going to multiply negative 4 times 3 times 5 to get a negative 60. And then I'm going to multiply 2 and 3 in the bottom to get a 6. The next thing you're going to do is continue simplifying under the radical. So 256 minus 60 will give us 196. And if you just plug in the square root of 196, you're going to see that it is actually a perfect squared. So the square root of 196 is 14. And what we do at this point is we split up the numerator. So I'm going to have negative 16 plus 14 over 6. And then I'm going to have a negative 16 minus 14 over 6. And then I'll just come over here. I'm going to write out x equals, and then you're just going to simplify the numerator to get a negative 2 over 6, and then negative 16 minus 14 gives us a negative 30 over 6, which these will reduce. This will be a negative 1/3 and a negative 5. So our solutions here, notice that it came out, we could have actually factored this one again, like I said, but you know, why you might think, well, why do we, if we could factor it, the quadratic formula just takes a little longer than it would to factor it. So your best alternative on this one would be to factor it to solve it. But just showing you, if you couldn't, or if you didn't think it would factor, or you didn't want to try to see, you can always use the quadratic formula to get your answers here. It's just going to require you to do a little bit more work than what you would do with factoring. So the next one here, we're going to use the quadratic formula again. So we're going to negative b plus or minus the square root of b squared minus 4ac all over 2a. I would recommend every time that you use this that you write it out. To use the quadratic formula, we've got to make sure this is equal to 0. Well, it's not, so what we're going to do is rearrange. So I'm going to subtract the 3. I'm going to put this in descending order. And then what I'm going to do is locate A, B, and C. So A is going to be 2. B is going to be a negative 4. C is going to be a negative 3. And then what we'll do here is we're going to replace. So what I'll do is I'm just going to write out, instead of me having to do like I did previously, what I'm going to do is come in and fill in with this different color here. So the opposite of B, so our B is a negative 4. So notice what we have to do there. We've got the formula always has a minus. Our B can be positive or negative. Well, if it's negative, what's going to happen? That double negative is going to change to a positive. When I replace my B in here, because I've got a negative 4, I want to make sure I put that in a parentheses and square it. Because if you plug it in the calculator, if you don't put the parentheses around it, remember any number when you square it is always positive. So if you don't put the parentheses around it, the calculator, instead of a positive 16, will give you a negative 16, and then you'll get the wrong answer. So I'm going to replace, I've got 4, A is going to be 2, C is a negative 3, and then on the bottom, I've got A again, which is a 2. Once you get it substituted in, then you're going to simplify the discriminant. Remember, the discriminant is what's under the radical. So that double negative becomes positive. So I'm going to have a negative 4 squared is a positive 16. And then I'm going to multiply negative 4 times 2 times a negative 3 to get a positive 24 over 4. Then we're going to add 16 and 24. So that's going to give us the square root of 40. I'm just bringing everything else down. Now, if you leave the answer like this, it's technically correct, but it's not simplified. So you have to simplify. If you go back to simplifying radicals, what we want to do, I'm going to make a little side note over here, is I want to take the square root of 40 and I want to break it down into a perfect square factor times a number. So I know that 4 is a perfect squared and that 4 times 10 is 40. What we can do here is we can split the square root of 4 and the square root of 10. because we know the square root of 4 would give me 2. I can't do anything with the 10, so I'm just going to leave it under the radical. And then I'm going to replace the 40, the square root of 40, with the 2 square root of 10 over 4. Now, what we need to do is we're going to look at, you're dividing this term and this term by 4. So when we divide here, you're saying 4 divided by 4 and then 2 divided by 4. So what I want to do here is, I'm just going to draw a little line around it, is I want to reduce that 4, 4, and 2. 2 is common, so what I'm going to do is divide what's in the orange by 2. So that would give us 2 plus or minus, 2 divided by 2 is an understood 1, so I'm just going to write the square root of 10. This is understood 1 right here. Over 4 divided by 2 is 2. So if this is your answer right here. But I could also split it up, and I could do this. I could say 2 plus the square root of 10 over 2, comma, 2 minus the square root of 10 over 2, and then close my solution set. I hope you have enjoyed this lesson and that it's been helpful. Please let me know if you have any questions.